So this is part 6 of the trig functions videos. We're going to look at transformations of sine and cosine graphs. So we'll start by reviewing what the sine graph looks like and how it's created, same with the cosine, and then we'll look at graphing form of sine and cosine. We'll see one cycle of each of the parent graphs, and then we'll go through some examples. Alright, so let's start by looking at how y equals the sine of x is created. So remember that we had this unit circle. So we know that it's a unit circle, meaning the radius is 1. Okay? And so any radius that I draw in here is going to have a length of 1. And if I drop a height down, that had a value of the sine of theta. Theta being the angle of rotation. Okay, and then the base length here, the x value, we said was the cosine of theta. So when we start trying to graph y equals the sine of x, or the sine of theta, what we really have on our independent axis, our x-axis, is angle of rotation. And so we're inputting an angle of rotation, and we're getting out the height of a point in the unit circle when it's been rotated so many degrees or radians. So I'm going to call this y-axis height. Okay, and so when I start doing this, I'm going to use green because that's the color that I used in the unit circle. When I've rotated 0 radians, I'm looking at this line here. And this line here has a height of 0, so that point's going to go at 0, 0. When I've rotated, maybe we'll say pi over 4 radians, I'm at a height of the square root of 2 over 2, which is approximately 0.7. So when my input is pi over 4, my output is about 0.7. So I'm going to estimate it right there. When my input is pi over 2 radians, my output is 1. So I'm all the way at the top of my curve here. Okay, and then we're going to rotate over to pi radians, and we get back down to a height of 0. So we're going to see this symmetry. You know, it goes up, and then it comes back down. That wasn't very symmetrical. Something like that. Okay, and then when we rotate past pi radians, past 180 degrees, we're going to get these heights that are negative, going all the way down to -1 at 3 pi over 2 radians, and then coming back and hitting 0 at 2 pi. So this is the graph of y equals the sine of x. The next one we're going to look at is y equals the cosine of x. So same idea, but this time as our radius rotates around the unit circle, we're tracking the length of the base. Okay, so now this y-axis is not the height in the unit circle, but the length of the base in the unit circle, while our independent axis is still angle of rotation in the unit circle. Alright, so when we've rotated 0 degrees, I have a base length of 1 because it's reaching all the way out to the radius of the circle. When I rotate 90 degrees, or pi over 2 radians, that's a straight line, right? So the base is 0. There's no triangle drawn in there. When I rotate pi radians, I've got a base length of -1. 3 pi over 2 radians, or 270 degrees, has a base of 0. And then at 2 pi, I'm back out to a base of +1. So I'm getting a graph that looks something like this. Okay? And so that's one full cycle of the cosine function. We're going to talk more about that on a different slide, but that's how we created it. Alright, so here is graphing form of the sine function. If I wanted to turn this into graphing form of the cosine function, I would just trade out these letters in here to be cosine instead of sine. Okay, so it's exactly the same. All of the parameters mean the same thing. It's just a different starting point. Like it's a different shape. Well, the shape is the same. So different starting point, I'll say. Okay, and the other thing is that sometimes you're going to see parentheses here, and sometimes you're not. Alright, so we want to be able to see it either way and be able to sketch a graph either way. Okay, so in yellow we've got that amplitude, the vertical stretch factor. B is our frequency, the horizontal stretch factor. H in purple is our horizontal shift. Notice in graphing form that says minus H. So if I have a horizontal shift of 5, I'm shifting 5 units to the right, that's going to say x minus 5 inside the parentheses. So the horizontal shift moves in a direction that might be counterintuitive based on the sign inside the parentheses. And then K in green is where our midline goes, that's our vertical shift. So let's experiment a little bit. We've got this graph of y equals sine of x. Notice that the midline is on the x-axis, that the maximum output is y equals 1, and the minimum output is y equals negative 1. So we're going to kind of keep track of those horizontal lines as we go through. When I add a curve in here, so you'll see as I go from the red curve to the blue curve, all I've done is I've multiplied the function by 2. So that's changing my vertical stretch factor. This output, when we input pi over 2, we would normally get out 1, and now we're getting out something that is twice as big. Alright, so if we would normally get out, that looks like 6/10, now we're going to get out 1.2. We can see also that the outputs that were negative now have a value that is twice as big, but they stay negative, right? We're multiplying a negative number times 2, so it gets even more negative. So this has the effect of stretching all of the points in the function away from the x-axis. That's a vertical stretch. We can also have a vertical stretch that is in between 0 and 1. So if we have an amplitude of 1/2, we're going to have outputs that get smaller. So where my output would have been 1, now my output is 1/2. So all of the outputs are going to become smaller and get closer to the x-axis. So that's a vertical compression. The amplitude handles both of those effects. The other thing the amplitude can do is it can flip the whole function over the x-axis. So if we have a negative amplitude, then we're going to get a sine curve that starts at the midline and goes down from the y-axis, like off of the y-intercept, before it goes back up. Alright, but notice that our maximum and our minimum y values stay the same. Now I can have a negative amplitude that flips it upside down and stretches it vertically. So here's an example of an amplitude of -2. Alright, the next transformation, the next parameter we're going to look at is the frequency. So the frequency is the number of full cycles that happen within 2 pi radians. So I usually look at between 0 and 2 pi, but it can be between, any two x values as long as they're 2 pi radians apart. Alright, so the parent function here has a frequency of 1 because we go through 1 full cycle between 0 and 2 pi. Here I'm going to change the frequency, so now we've got a frequency of 2. So looking at that orange curve, I'm going through, there's my first cycle, and there's my second cycle. Okay, and that happened within 2 pi radians. Alright, so that was changing that parameter here, the 2. I can also have a frequency that is less than 1. So I get through less than 1 whole curve within 2 pi radians. So again, I just want to point out that maximum, midline, and minimum y values are staying exactly the same. The only thing that's happening now is that our function is being stretched out horizontally. Alright, so now we only get through half of a cycle between 0 and 2 pi radians. I can combine those two transformations So I can get through only half of a cycle in 2 pi radians and vertically stretch my y values by changing the amplitude to 2. Here's an example where I've got an amplitude of 2 and a frequency of 3. So there's one full cycle, there's my second cycle, and there's my third cycle, in between 0 and 2 pi radians. Alright, so the next parameter we're looking at is horizontal shift. There's my parent function. We're looking at a sine curve. So sine starts, it has a y-intercept at the midline, and then it travels up, it hits that maximum y value, and then goes back down and hits that minimum y value. And then it ends back at the midline. So that's one full cycle of a sine curve. If I change the horizontal shift, so here I'm adding pi over 2, this is going to be a shift to the left of pi over 2 radians. So notice that all of my points have been shifted to the left, pi over 2 radians. And now my starting point, which used to be at 0, 0, is still on the midline, but now it's at a x value of negative pi over 2. So I'm looking for where do I see the beginning of a sine curve. And I could see it here, right to the left of the y-axis, pi over 2 radians, or I could think about it as here, because this 3 pi over 2 is also on the midline, and the sine curve travels up from there. So I could say y equals sine of x minus 3 pi over 2, and that equation would get me the same exact graph. So when you're doing these, when you're finding an equation that fits a graph, you have a lot of different options because there are an infinite number of horizontal shifts that will give you the same picture. That's the nature of a periodic function. Alright, so here's a shift of pi over 4 radians to the right because I've got subtraction inside of the parentheses. Alright, so we're seeing that all of those points are moving to the right by pi over 2. Now I'm going to combine some. So here's an amplitude of 3/2. That's 1.5. My midline is still the same, but my maximum has gone up to 3/2, and my minimum has gone down to negative 3/2. Okay, so that's 3/2 units above the midline and 3/2 units below the midline. I've also shifted my starting point pi over 4 units to the right. So I'm looking for where does that sine curve intercept the midline and then travel up. And so that's a starting point for me. Here we've also included a frequency of 2, so that's the one change in this graph. And so I'm still shifting pi over 4 units to the right. I'm changing the frequency, so I'm going through one full curve and then a second full curve in 2 pi radians. And I've stretched vertically, so my amplitude is 1.5. So it goes up 1.5 units above the midline and 1.5 units below the midline. The last parameter we have to look at is vertical shift, which we can also think of as where the midline goes, because the midline is usually at y equals 0, right on the x-axis. When I change the midline and I shift up a unit, when I change the equation and I shift up a unit, the midline also shifts up a unit. So all of these points are going up 1 unit, and the midline, which was here, is also shifting up 1 unit. So there's an example where I've shifted down down half of a unit. So the midline is at y equals negative 1/2. And then I can combine. So here I've got a midline of negative 1, an amplitude of 1/2. So my maximum and my minimum y values are 1/2 of a unit away from the midline. And I've got a frequency of 2. So I go through one full curve, and there's my second full curve in 2 pi radians. So the last example here has an amplitude of 1/2, a midline of -1, so there's my midline. My maximum is half a unit above, my minimum is half a unit below. I've got a frequency of 2, so there's one full curve, and here's my second full curve in 2 pi radians. And from the beginning of my sine curve, this has been shifted pi/4 radians to the right. Alright, so this does look to me like a cosine curve that's been flipped upside down, but we'll talk about that in the examples. Alright, so let's just look at one full cycle of each of these. If I have a sine curve with a positive amplitude, I'm starting at the midline, going up, down, and ending at the midline. So there's my midline. I've got a maximum y value up here, and a minimum y value down here. Okay, the full cycle ends at 2 pi, so that's 2 pi. Half a cycle is at pi, and so I've got my maximum at pi/2, my minimum at 3 pi/2. The negative sine curve is going to look exactly the same. It's going to come off of the midline going down, though, and then cycle up and end at the midline. Cosine will start at the maximum, hit the midline, the minimum, the midline, and then end at the maximum. So it's going to be at its lowest. It's going to be at its lowest at pi radians. It's going to end its cycle at 2 pi radians, and it's going to intercept the midline at pi/2 and 3 pi/2. Cosine with a negative amplitude will start at the minimum, go up, and end at the minimum. Alright, so let's get into some examples. Here, what I always start by doing is just listing out my parameter. So I've got an amplitude of 2, a frequency of 4, a horizontal shift of 0, and a midline of -1. I also am going to do my period here. So period is something that we haven't talked about yet. Period is the length of one cycle. So let me just give you an example. If I had a frequency of 3, so I got through 3 full cycles between 0 and 2 pi, the period is the length of one of those cycles. So what I do to find the period is I take 2 pi and I divide it by the frequency. So remember, frequency is the number of cycles in 2 pi radians. So if I take 2 pi radians and divide it by the number of cycles, I'll get the length of one cycle. Alright, so in this case, with a frequency of 4, my period is 2 pi divided by 4, which simplifies to be just pi/2. So I'm going to set up my graph now. I've got my x-axis and my y-axis. I'm going to start this one at the midline. So I'm going to go ahead and put my midline in at y equals -1. And let me just mark that as my midline. That's at -1. My amplitude is 2, so my maximum y value is going to be 2 units above the midline. So that's going to be a maximum y value at y equals 1. And 2 units below -1 is a minimum y value at x equals -3. So I've got that set up. So really what I've just done is I've taken care of the midline and the amplitude. So I have to hold less information in my head while I do the rest of my sketching. The next thing I want to think about is how to scale my x-axis. So I've got a period of pi/2. So what I'm going to do is I'm going to put pi/2 out here a little bit, because I know that's going to be one full cycle that ends there. So here I can fit a second full cycle in, and that's going to be at pi radians. Now I know each cycle, each period of a sine or cosine curve has 4 distinct parts relating back to those 4 quadrants in the unit circle. So I'm going to divide my 1 period into 4 equal sections, and I usually go to the halfway point first. So half of pi over 2 is pi over 4, half of pi over 4 is pi over 8. And so now I know that each of these sections on my x-axis is pi over 8 big. So I've got 1/8, 2/8, which is a quarter, 3/8, so that's 3 pi over 8, 4/8, which is a half, 5 pi over 8, 6 pi over 8, which is the same as 3 pi over 4, and then 7 pi over 8. Okay, so there are my scale, there are my x and y axes scaled. And so I'm doing a sine curve. So just to give myself a little reminder, sine starts at the midline, goes up, hits the midline, goes down, and hits the midline again. So as I put my points down here, I want to start at the midline. Oops, that's not my midline. I want to start at the midline. I want to end at the midline, pi over 2 radians later. And I can see here, there's my start and end points right in the middle of my curve. I'm also at the midline. And then a quarter of the way through, I'm at the maximum. 3/4 of the way through, I'm at the minimum. And so I'm going to go through and put those points in. I have no horizontal shift, so there's nothing to take care of there. And I can just go ahead and connect the dots. Alright, and there's my sketch. Here we've got y equals 3 times the cosine of 2 times x minus pi over 2 plus 1. So I've got an amplitude of 3, a frequency of 2, a horizontal shift of right, because that's minus pi over 2. I've got a midline of 1, and my period is 2 pi over 2, which is just 1 pi. I'm doing a cosine curve with a positive amplitude, so there's my little reminder sketch of what the shape looks like, and now I'm going to go ahead and set up my x and y axes. So I'm going to start by drawing in my midline at positive 1. My amplitude is 3, so I'm going to go 3 units above my midline. And there's my maximum. In this case, that's going to be at y equals 4. And then 3 units below my midline is y equals -2. So I've taken care of the amplitude and the midline at this point. My period is pi. So I'm going to put 2 cycles on my graph. The first one's going to end at pi, the second one's going to end at 2 pi. I'll split each of those periods into 4 equal sections. So half of pi is pi over 2, half of that is pi over 4. So this is 3/4 of pi, 4/4 of pi, 5/4 of pi, 6/4 of pi, which is the same as 3/2, and then 7/4 of pi. Let's see, I'm doing a cosine curve, so I've done my little sketch. I'm going to start my cycle at the maximum and end my cycle at the maximum. Exactly halfway through, I'm going to be at the minimum, so that's pi over 2. And then 1/4 of the way and 3/4 of the way through, I'm going to be at the midline. So I can go through and put all my points in. And now, now I've taken care of the frequency and the period. So the only thing left to take care of is the horizontal shift. So I'm going to switch to red dots for this. I'm going to move each of them pi over 2 radians to the right, which is 2 tick marks. So this point moves here, this point moves here, Alright, so I'm seeing that those points on the midline actually lie on top of each other. So those all kind of stay where they are. This point is going to move from pi over 2 radians to pi, from pi to 3 pi over 2, from 3 pi over 2 to 2 pi. So I'm now playing connect the dots with my red dots. And there's my graph. Alright, I got 2 more examples for you. I would suggest pausing the video once you see the example and trying it yourself. I will say though that this one is the first example we're seeing with a negative amplitude, so just be careful about that. So an amplitude of -1/2, a frequency of 3, a horizontal shift to the right, pi over 6, a midline of +2, and my period is 2 pi divided by my frequency, so that's 2 pi divided by 3. Set up my axes here. See, I've got a midline at +2, so I'm going to just put my x-axis right at the bottom of my curve here. I know it's all going to be above the x-axis. Alright, midline is at +2, so let's scale this out. 1, 2, 3, 4. Here's my midline. Now I'm just realizing that my amplitude is only 1/2, which would mean my maximum value would be right here, which just seems super close to where I'm drawing. So I'm just going to change up my scaling real quick. I'm going to make my y-axis a little bit longer. Put my x-axis right at the bottom, and then I can have a little bit more space. So I'm going to call this 1, 2, and 3. Alright, so my midline is at +2. My amplitude is 1/2, so I'm going 1/2 of a unit above to my maximum, and 1/2 of a unit below to my minimum. So there I've taken care of amplitude and midline. I'm going to scale out my y-axis now. I'm sorry, my x-axis now. So I'm going to put one full curve ending at 2 pi over 3 here. Second full curve will end there. Divide those up into 4 equal pieces each. 1/2 of 2 pi over 3 is 1 pi over 3, and 1/2 of that is pi over 6. So my tick marks are going up by pi over 6. 1/6, 2/6 is a third, 3/6 is the same as a half, so that's pi over 2. 4/6 is the same as 2/3. 5 pi over 6 is next. 6 pi over 6, which is a whole. 7 pi over 6 is after that. And then 8 pi over 6, which is the same as 4 pi over 3. Alright, so I've got my x-axis scaled. I'm going to give myself a little sketch here. I'm doing a negative sine curve, so that's going to start at the midline and go down first. So I'm going to start at the midline. I'm going to end at the midline when my x value is 2 pi over 3. Right in the center of my curve, I'm at the midline, but a quarter of the way through, I'm at the minimum rather than the maximum, and then the maximum after that. Alright. So let me just put those points in real quick. And now I need to shift to the right by pi over 6. So I will switch to red dots. This one goes here. So I'm just shifting all of my red dots over by pi over 6. And now I can connect the dots. Alright, and there's my curve.